We are going to record the Raspberry Pi GPIO tutorial, and I have teeth pain, so I my voice will be slow today. But let me tell you Raspberry Pi GPIO tutorial and the basic explaining. In the Raspberry Pi and GPIO tutorial, you have many things. First of all, first of all, in the Raspberry Pi tutorial, we are going to take a look at all the basic of the GPIO pins, and also known as a general purpose input and output pin. So these pins are the communicate with the other circuitry such as extension board, custom circuit, and much more. You can look this image also, so for better understanding. This is GPIO pins. These are the GPIO pins, and this is general purpose input and output pins. Now the experimenting with the GPIO is risky and has a chance to breaking and your Raspberry Pi. Knowing the power limitation of the GPIO pin and also understanding what you are plugging in the most. The equipment that I use in this Raspberry Pi GPIO tutorial is like a Raspberry Pi micro SD card, 8 GB plus recommended, Ethernet cable or Wi-Fi, 100 ohm resistor, red LED, GPIO breakout kit, breadboard and breadboard wire, a Raspberry Pi case with access to the GPIO pins. Now you can understand the more about the get started with this GPIO tutorial. We take a look at different types of the pins that are available, how to enable the module, what is breakout kit, and finally how to build the program in simple circuit. If you are an owner of the Raspberry Pi B+, 2, 0 or 3, then you will have 240 pins in total. The earlier models such as Raspberry Pi B have just 26 pins. You can see below for the Raspberry Pi GPIO pin out diagram, and we have included all three iteration of the Pi for the pin out diagram. If you want, you can download this PDF also. These are the Raspberry Pi B+, 2, 3 and 0. Raspberry Pi revision. As you can see, there are the more than just your standard pins. There are the some that reference I12C, SPI and UART. GPIO is your standard pins that can be used to turn device on and stop and off. For example, the LED 12C inner integrated circle pin allow you to connect and talk to hardware module that support this protocol. 12C protocol. This protocol will typically take up 2 pins. SPI serial peripheral interface bus pins can be used to connect and talk to SPI devices. Pretty much the same 12C but make use of a different protocol. UAR, universal asynchronous receiver transmitter, is the serial pin used to communicate with other device. DNC stand for do not connect. This is pretty self-explanatory. The power pins pull power directly from the Raspberry Pi. GND are the pins used to ground your device. It doesn't matter which pin you use as they are all connected to the same line. So all this might be daunting at first, but it's pretty easy once you get going. A lot of the abbreviation and technical jargons is easy to turn people off straight away. Configuration and using the pin. In this section we see briefly touch on how to set up these pins so that you can use them on the Raspberry Pi. We will go a lot more into actually programming and using the pins in the future Raspberry Pi project. In this example and in the future project, we will using Raspbian. If you have not got it installed, then you can find out how to install the latest version of the Raspbian installation guide. And if you are on the latest version Raspbian, then you can start programming and using the GPIO pins without needing to do any extra configuration. However, I recommend that you can update your Pi in the latest package anyway. If you have not done this yet, then you can do it by running the following command: sudo apt get update, sudo apt get update and upgrade. So if you don't have the GPIO package installed, you simply install it by running the following command: sudo apt get install rpi.gpio. Configuring Raspberry Pi I2C, setting up the 12C pin on the Raspberry Pi is super easy, and will only take a couple of minutes to do. So firstly, we go to Raspberry Pi configuration tool by entering the following command: terminal, then copy sudo Raspberry Pi in the interface option, and then 12C enable 12C by the selecting yes. The Pi should not alert you to that 12C will be enabled after reboot. It will then ask you want to load it by default. Select yes if you plan on using I2C every time on the Raspberry Pi boot up. Now we want to make sure that it has successfully enabled the necessary module. To do this, enter the following command: ismod grep I2C. This command will return any module that are running starting with I2C. It should return something like the I2C BCM2708. Configuring Raspberry Pi SPI. Configuring the Raspberry Pi SPI is the much like the 12C and is super easy. It will only take a couple of the minutes to do. Firstly, go on Raspberry configuration tool by entering the following command: sudo raspi.configuration. Once the configuration tool has loaded, go to interface option and then to the SPI. Enable SPI and it will tell you that it will be enabled after reboot. After that, it will ask if you want it to be loaded by default. Only select yes if you plan on using it every time the Pi boot up. To check that SPI is successfully up and running, use the following command: smod grep SPI. This command will return any module that are running starting with SPI. It should return something like SPI BCM2835. Make sure you have restarted your Pi before checking to see if the module has been loaded. Using a breakout kit. So a breakout kit can allow you to take all the pins by the breakboard and different devices. This could make the lot easier and safer than working in around the Raspberry Pi. There are the few different types of the breakout kits that you are able to buy for the Raspberry Pi GPIO pin. Personally, I prefer the T type as they are easy to read and use. If you are looking for a breakout kit to buy, then be sure to check out the equipment list above. Programming with the Raspberry Pi GPIO pins. So programming with the GPIO pins on the Raspberry Pi is typically done using the programming language Python. This particular circuit and code is super easy to get going and would not take you long at all to complete. If coding sound like it may be a little too involved for you and would prefer a simple solution, then something like Raspberry Pi KNE might interest you. That the software package allow you to add a sensor, control GPI pins and lots more than super easy user interface. GPIO board versus GPIO BCM. There is a massive difference between these two different modes, and it is up to you which one you want to take advantage of for your project. Both have their own pro and cons. GPI board and GPI board reference the physical numbering of the pins. For example, the top left pin is 1 and the top right pin 2. It continue to count upward as you go from the top to bottom until you run out of pins. In a diagram, you can see this numbering in the middle of the each group. GPIO BCM is the Broadcom SoC channel numbering. In the diagram above, in this diagram, so in this diagram you can see for example on the Raspberry Pi the pin below 3B3 and GPIO 2, so the number for the pin is 2 in the BCM mode. A downside of the BCM is that they have changed between version Raspberry Pi revision 1 versus Raspberry Pi revision 2 and may do in the future. If you want to be safe, I recommend sticking to GPIO board, but as I said earlier, it is up to you how you want to reference the pin. The code for a simple LED circuit. If you're happy to code and learn lots about Python, then check out my example below. Firstly, let's set up a little circuit. I have a helpful easy diagram to follow below. If you have a breakout kit, the circuit will obviously be a bit different since your wire will come from the cobbler. Alternatively, simply connect the positive end of a LED to the pin 7 GPIO 4 and the negative into a resistor that connect to the ground pin. So this is, now let's create a Python file so that we can type out our Python script. Sudo nano led slash blink.py. Let's write out the little script. It's important. Python white space sensitive. For example, in the for loop, make sure you have 4 spaces for anything within the loop. To explain a little further, the GPIO dot output 7 true line will need to have 4 spaces before it. Slash import the GPIO input. Import RPI respiratory.gpio as GPIO import time GPIO dot set mode GPIO board GPIO setup GPIO dot out hashtag loop through 50 times for I in the range 50 GPIO output 7 true time sleep 1 GPIO output 7 false time sleep 1 GPIO cleanup. Now exit and save by pressing CLT or LX and then Y. If you run our little script, the script should come to life. You can run a Python script by doing the following command. It is also important that you run it as a super user using sudo python led / blink.py. I hope that this tutorial helped introduce the basis of GPIO. As I mentioned earlier, this is a guide. I will doing a lot of projects that use the Raspberry Pi GPIO pins in the future. This range of the project include using motion sensor, temperature gauge, controlling motor and much more. If you have any question, ask in the comment section so I can reply you.